Hello, everyone. I'm Ranxi. I'm an infrastructure engineer in Verda Platform team of LINE. We provide the managed Kubernetes service to LINE developers. In the last year, with the increasing of users on the managed Kubernetes service platform, we encountered the different challenges. One of them is to provide a safe, flexible, and zero-downtime Kubernetes cluster upgrade solution to our users. Today, I will share how we think about cluster upgrade solution and how we design and implement it. First of all, I would like to introduce myself. I joined LINE in September 2019. I was responsible for developing and maintaining the LINE Managed Kubernetes Service platform. And I'm also in charge of the reliability improvement work within my team. So here is the agenda of my topic today. Firstly, I will introduce the architecture of LINE Managed Kubernetes Service. Secondly, I will share what is the desired cluster upgrade solution in our mind when we got this challenge. Thirdly, I will share the investigation result on some of open source softwares about how they do the cluster upgrade work. Finally, I will introduce how we design and implement our own Kubernetes cluster upgrade solution. So first of all, let me introduce the architecture of LINE Managed Kubernetes Service. LINE Managed Kubernetes Service platform includes the three parts. First one is the Gateway API. It is responsible for handling users' requests of a cluster and node operation. The Gateway API doesn't include the actual cluster and node operation logic. It just validates and forwards those requests to the backend cluster managed service. The second part is a rancher. In LINE, we customize rancher to be an automatic multiple cluster management service. The third part is item manager. It is responsible for developing necessary control plan services that are mainly used by our operators, like FluentD. It helps us to collect the necessary system components logs for better troubleshooting work. In LINE, we provide the single cluster for each development team or each business product. Now, in LINE Managed Kubernetes Service, we currently have about 570 clusters and over 8,000 nodes managed by about 10 developers. Some of clusters already have more than 150 nodes. It is still increasing. After we knew the architecture of the Kubernetes Managed Kubernetes Service platform and the scale info, let's go to the cluster upgrade topic. When we would like to have a cluster upgrade solution, we want to imagine a desired solution without considering any actual difficulties and existing experience first. That is pretty important for us because the issues of cluster upgrade that each team encountered may be different. We don't want the experience limits our thought in advance before we try to resolve and think about it by ourselves. So now, let me share with you what is the desired cluster upgrade solution in our mind. A desired cluster upgrade solution should be safe, flexible, and no downtime on the application side. I will explain what actual features that the desired cluster upgrade solution should include from those three perspectives, one by one. In the safety part, the first feature we would like to have is upgradable checking. It is used to check if a cluster satisfies all upgradable conditions before we touch it. The first checking item is a Kubernetes version skill checking. For example, skip multiple minor versions upgrade should be banned due to the Kubernetes doesn't provide any compatibility promise on it. The second one is the cluster health checking. We also should make sure that cluster doesn't have any obvious issue before we touch it, like some of nodes are not ready before upgrade. If that issue happens, we should fix it first, right? And not continue the upgrade stuff. The third one is the resource compatibility checking. Because some of Kubernetes APIs may be deprecated or removed eventually in the new version. In that case, if some users' resources were created by them, it's better to migrate those resources to the latest and compatible versions for avoid the expected compatibility impact. In addition to the upgradable checking, the second feature we would like to have is a cluster rollback mechanism. We hope the cluster can be rolled back to the previous healthy state and the Kubernetes version when something was wrong during the upgrade process automatically. That is pretty important for us because we don't want a feature introduce that much reliability risk to users' clusters. Besides, the manual rollback mechanism is also needed when user may find some issues after the cluster was already upgraded, like their applications cannot work on specific Kubernetes version due to the compatible issues. The third feature we want to have is that the upgrade control plan and worker separately. As we know, the user's applications usually run on the worker nodes. They may need to collaborate with the control plan of the Kubernetes cluster, like sending requests to the Kubernetes server for creating or updating the specific resource objects. In that case, leaving enough time for users to check if their application works fine or not with the new version of the control plan is pretty necessary from the safety perspective. From the flexibility perspective, we would like to support a flexible way to choose which worker and when those selected workers' nodes are upgraded as user want. There are two reasons to enforce us to consider this feature. The first one is, according to the experience of discussing with the LINE developers sometimes just want to upgrade one or few worker nodes to the new version and develop testing applications on them to confirm if they work fine or not with the new Kubernetes version. Besides, some users will not upgrade worker nodes as a time period when there are more user requests. They may do it as a midnight, they may do it as a morning for reducing the reliability risk on application side. From the application's perspective, we hope our upgrade solution will not cause any downtime of applications. Two conditions that our cluster upgrade solution should satisfy. The first one is, during the upgrade process, the external and internal network traffic can be handled by the user's application normally. The second one is, applications can communicate with the control plan, specifically Kubernetes server, well during the upgrade process. That's all we can come up with the feature that the desired cluster upgrade solution should include. After we already have this whole picture in our mind, we would like to check if some parts of our solution are already supported by some open source softwares so that we can reuse them for avoid the repeated work. Now, let's go to the open source case study part. I will share our investigation results of the cluster upgrade solution on 2 open source softwares from the perspectives where we consider our desired solution: safety, flexibility, and zero downtime. As I mentioned, the LINE managed the Kubernetes service is customized based on the Rancher. So Rancher is definitely the first open source software that we investigated. In the safety part, for the cluster upgradable tracking feature, Rancher only supports the Kubernetes system component tracking, like accessing the healthy, the interface of Kubernetes server, kube controller manager, but not support the Kubernetes Verda queue tracking and node health state tracking and compatibility checking. For separate upgrade feature, Rancher doesn't support it, unfortunately. It means once we trigger the upgrade process of a cluster, only 2 situations may happen. First one is control plane upgrade failed and it is rolled back. Worker of that cluster will not be touched. The upgrade process is stopped. The second situation will be control plane and the worker will be upgraded in a single place at the same time. For the cluster rollback, the Rancher supports the manual Rancher only supports the manual rollback mechanism. That is good due to the user may want to roll back their cluster when they found something wrong after the cluster is already upgraded, like I mentioned in the desired upgrade cluster solution part. But the disadvantage of no automatic rollback mechanism is rollback process only can be triggered until user or operator found that cluster is unhealthy. In that case, the outage may happen on user application side during this period of time. So now, let's go to the flexibility part. In the flexibility part, Rancher provides the batch size upgrade strategy for the control plane and the worker. It is insufficient in the huge scale cluster that has lots of control plane or worker nodes, because we can upgrade maybe 10 or 20 nodes at a time, right? But it reminds us, Rancher only can confirm that the number of the upgradable worker at a time. Only can confirm the number. Please notice, but don't confirm that which nodes are selected and upgraded. This strategy is fine for control plane because our original plan for upgrading control plane is that upgrade them in a single process at the same time. But it's not flexible enough for workers because some of users may want to upgrade the few worker nodes where no production services are deployed on to test the compatibility of the new Kubernetes version from the application perspective. From the application perspective, Rancher picks up the rolling upgrade strategy for the control plane. It means the existing application have one control plane node to access during the upgrade process at least. And because the network communication of the application rely on the rules of the IP tables and cluster or network, cluster network stack, the worker upgrade process will not touch them. It means the Rancher provides that can complete the support for the zero downtime on the application side. That's all about the Rancher on the cluster upgrade topic. You can see it does something good like providing the automatic rollback cluster mechanism, provide the manual rollback cluster mechanism. But what it does on some points are still not enough, like cluster upgradable checking. For learning the experience where the rancher doesn't do it well, we choose another popular open source software, Kubeadm, as a second project to investigate. So Kubeadm is the Kubernetes official cluster provision and upgrade tool. Lots of users, lots of the developers are using it to construct their own private Kubernetes cluster. In the safety part, for the upgradable tracking feature, the Kubeadm supports the Kubernetes system component health checking and the node state checking. It's not surprised that the Kubeadm also supports the Kubernetes Verda skill checking due to it is a Kubernetes official solution, right? For the separate upgrade feature, the Kubeadm not only supports the upgrade control plan and worker separately, but also supports the upgrade multiple nodes with a single role separately. For example, it can support the upgrade control plan one by one manually, even if we have a bunch of the control plan nodes in the specific Kubernetes cluster. For the cluster rollback, the Kubeadm only supports the automatic rollback mechanism, not support the manual rollback. The automatic rollback process is triggered when some error happens during the upgrade. For the flexibility part, the Kubeadm does better than the rancher on the upgrade time on the selected nodes side. But the disadvantage in the Kubeadm is it doesn't support the batch size upgrade. It is definitely an operation disaster when a cluster our developers want to upgrade includes the hundreds and 1,000 nodes, right? Because you need to upgrade them one by one, not the batch size. You cannot choose upgrade the multiple them at the same time, at a time. Because the flexibility of the upgrade approach, rolling upgrade control plan is feasible in the Kubeadm side. For worker, it's the same with the rancher. So there isn't a downtime issue on the application side too. When we investigated the Kubeadm. Here is the table I made to summarize the behavior of the different open source software on necessary features. You can see here, some of features rancher did well. Some of features Kubeadm did well. For safe cluster upgrade solution, rancher doesn't do it well. I want to say Kubeadm is better in those parts, but is still missed some checking stuff that we would like to have, like API compatibility checking. The API compatibility checking is pretty important for us because if any compatible issues still in the user's cluster and we proceed the upgrade stuff, that may break down some user's application. That caused the application's downtime on the user's application side. That is the result we definitely want to avoid. Especially for the rollback mechanism, rancher and Kubeadm have different advantages. The rancher supports the manual rollback, right? But the Kubeadm supports the automatic, the rollback. But we want to have both of them in the single solution based on the requirement from the LINE developers when we discuss with them. For flexible upgrade, cost upgrade solution, Rancher doesn't do it well, honestly. But Kubeadm also has some issues in choosing the upgradable worker site. It seems like no one, the open source software can satisfy all of our requirements for the cost upgrade solution. In that case, which direction we should go? That's the question I have to ask ourselves before we touch any design and any implementation, because the direction is very important. We may choose implement it from the scratch, right? That is one of the way we can have a more, we can have a more controlling ability to this class upgrade stuff. But we also can choose reuse some stuff of the open source software to avoid the repeated work. That is why we investigated some open source softwares, right? So finally, we choose the fusion way. We use the Rancher's class upgrade solution implementation as a basis, and improve the Rancher logic that doesn't implement the necessary features completely. We reuse some of them and we enhance them. If there is any feature that Rancher missed, totally missed, I mean, that feature we want to have, but Rancher doesn't implement, like API compatibility checking stuff, we can implement it as a totally new feature by using the plugin mechanism in the Rancher side. Rancher really provide a flexible, the mechanism to the developers to implement some their own business logic based on the framework that Rancher provides. And for this kind of the new feature implementations, we also can reference some best practice of the Kubeadm that we investigated, like for example, the Kubernetes Verda queue checking. That part, the Kubeadm did pretty well, and we can reference it and re-implement it in the Rancher side. That will improve our confidence about this type of logic, because Kubeadm, this logic in the Kubeadm side is already used and validated by the lots of users all around the world. Now it's time to talk about how our upgrade solution looks like and how it works. That is the most important part in this slide. So let me introduce it. The first improvement that we implemented on the Rancher side is separating the upgrade process of control plan and worker. The control plan will be upgraded first, and the user can choose when and which worker nodes are upgraded. That is a small improvement we did based on the Rancher implementation. So for control plan upgrade logic in our solution, it can be explained by three phases: pre-upgrade, upgrade, and post-upgrade. I will introduce which improvement we did for Rancher existing feature and which new feature we added in each phase. Then I will introduce the upgrade flow in the simple way. The first feature of the upgradable checking we introduced in the pre-upgrade phase is Kubernetes Verda queue checking. We implement it by reference to the similar logic in the Kubeadm. Two conditions we set. The first one is upgrade control plan and worker can across the multiple patch versions or one minor version at most. The second one is the new version that worker node wants to go isn't greater than the current version of the control plan. They are all mandatory rules. If the new version doesn't satisfy those conditions, upgrade process should be stopped. The second new feature we implement in the upgradable checking part is the compatibility checking. When we plan to provide a new version, we usually get the compatibility change from the change log of the new version and the deprecated API list in the Kubernetes offshore document. Then we convert them into a compatibility report in a JSON format manually. Because the deprecation of the API doesn't happen on each new Kubernetes version, so this kind of manual work isn't too much. Next, we will get the actual resource list in the user's cluster and compare it with the compatibility report to return the affected resource part to users. It includes which resources are affected and the fixing suggestion. Here is the example we will return to users. You can see here, user can easily grasp the which resources in their cluster are affected and some fixing suggestions we give to them for getting them to fixing those compatibility issues. So if any compatibility issue still exists, the upgrade process will not be proceed. We will require user to resolve all of them before upgrade process continue. For cluster health checking, Ranch already implemented it partially, so we just did a small improvement. We added the etcd brain sprint checking by detect if multiple exist in the same etcd cluster or not. And we also added the node and healthy condition and the state checking by reference to the Kubeadm logic. The cluster health checking is not only used in the pre-upgrade phase, but also in the post-upgrade phase. It is for ensuring the upgrade stuff doesn't break the user's cluster. That's all new feature and improvement we did based on the rancher in the pre-upgrade phase. Now, let's check how upgrade control plan and how upgrade control plan flow looks like. In the upgrade control plan phase, or successful upgrading control plan workflow looks like this. It will get the necessary image map based on the desired Kubernetes version. Here is the example. Because some of control plan softwares we are using are only compatible with the specific Kubernetes versions. It means those softwares need to upgrade when they upgrade the control plan. Then it will check if the etcd needs to upgrade by diff the expected image version of the etcd and the current version. If it needs, doing the rolling upgrade on the etcd side. After that, it will do the rolling upgrade on the Kubernetes system component and control plan softwares on the control plan nodes. Finally, it will proceed the cluster health checking, as I mentioned, in the pre-upgrade phase to ensure the cluster is still health after the control plan upgraded. This whole upgrade control plan process will be done automatically. The control plan upgrade flow explained is a successful scenario previously. When something goes wrong during the upgrade, the rollback mechanism should be triggered automatically, as I mentioned in our expected cluster upgrade solution. So any step that is marked as a purple color in this slide is failed, automatic rollback will be proceeded. Now, let me introduce how a cluster rollback process works. Unlike the upgrade process, the rollback process has a downtime because the rollback process needs to restore the etcd using the snapshot we took before. All etcd instances will be shut down during that time. In addition to the etcd restore work, rollback mechanism will also downgrade the Kubernetes system component and another control plan softwares that's compatible with the previous Kubernetes version, like DNS and the CNI plugin. Finally, the cluster health checking will also be proceeded for make sure the rollback held the cluster really. If there's automatic rollback still cannot make the cluster back to the health, you can see here, it will trigger the alert and involve our operator to do this troubleshooting work manually. The manual rollback is usually triggered by users in the post-upgrade phase, as I mentioned, when they found that their application cannot work with the new version of the control plan, especially for the Kubernetes server. They will execute the VKS CTL command, to root back the control plan. The VKS CTL is just as a similar command line tool with the kube control. It is provided by us to line developers to do the cluster and node operation. That is all stuff I want to share about the control plan upgrade process and rollback process. Now let's go to the worker upgrade part. For worker upgrade, I will skip the pre-upgrade and the post-upgrade phase because they are almost the same with the control plan. I will focus on the choosing the candidate worker and upgrade worker phase. In choose the worker phase, we implement the feature of using the node label selector to choose upgradable workers. Our user can choose to add the new or use the existing labels to mark the upgradable nodes. It is not only support the batch size upgrade like Rancher did, right? But also can confirm which workers will be upgraded like Kubeadm did. So in here, the new feature we implement by combining the Rancher and the Kubeadm, both of the advantage on them into the single solution in our site. So one of the examples in here is I used the VKCTL to label the worker 2 and worker 3 with upgrade equals to true label. After I ran the final command, I mean the VKS CTL upgrade worker command, both of them will be upgraded at the same time. So what's happened in the worker upgrading process? Let me share it with you. Here is the complete upgradable worker flow looks like. First, it will get the necessary image list based on the desired Kubernetes version. Second, it will build up an object called the node plan. This node plan includes the desired image and argument list of the kubelet and the kubeproc, because only kubelet and the kubeproc will run on the worker node, right? And some necessary files that Rancher has to create on each host, on each worker host, on like the Kubernetes server certificates file. Then it will check if the kubelet and the kubeproc needs to upgrade by diff the expected image version and actual image version. After that, it will execute the kubecontrol drawn node command to migrate the existing application on that node, and the new application will also not to be scheduled on it. Next, it will upgrade the kubelet and the kubeproxy with the new Verda image and proceed the health checking. Finally, after confirmed the worker node is upgraded successfully, it will add it back to the cluster by encoding it. That's all about how our cluster upgrade solution works and which feature and improvement we did. Now, let's check how it behaves compared with the Rancher and the Kubeadm. Here is the table that compares the line with the open source software in the cluster upgrade solution. Our upgrade solution supports all desired features. The hammer emoji in this slide indicates we improved the Rancher existing logic. And the sparkles indicates that is completely new features we introduced to our customer Rancher. So you can see here in our solution, so every feature in our desired cluster upgrade solution I shared with you previously are all satisfied, right? So it means in the LINE private cloud platform, we provide safety and flexible and no zero downtime on application side cluster upgrade solution to LINE developers. So that's all I would like to share with you guys about our cluster upgrade solution. So thanks for your listening.